Hello everyone and welcome to this video.
Time series data is essentially a sequence of data points recorded at specific time intervals. Pandas offers powerful tools to work with this kind of data, making it easy to manipulate, analyze, and visualize trends over time. Imagine you're a data analyst at an e-commerce company. Your manager has noticed some fluctuating sales trends, and your task is to analyze the sales data to uncover trends, identify seasonal patterns, and detect anomalies. In this tutorial, we'll guide you through the steps to make data-driven decisions. By the end, you'll be able to provide valuable insights that help optimize business strategies using Pandas. Let's talk about the data we'll be working with. Your company has provided you with daily sales records from the past 2 years. Before we dive into the analysis, let's take a quick look at the dataset to understand what we're dealing with. Alright, let's break this down. We start by importing the Pandas library, which is essential for data manipulation. Then we load our sales data from a CSV file using the red_CSV function. We specify the parse_dates parameter to ensure that the date column is recognized as a datetime object. This allows us to perform time-based operations. Additionally, we set the index column to date, making it easier to work with time series functions. Finally, we use the head function to display the first few rows of our dataset, giving us a quick overview of the data. The parseDates parameter ensures that the date column is recognized as a datetime object, which is crucial for performing time-based operations. By setting the index column to date, we make it easier to work with time series functions. Now, your manager is curious if there are any missing sales records. Let's find out. Missing values can really distort our analysis, so it's important to check for any gaps in the dataset. Let's take a look to see if there are any missing values. Here's what's happening in this code snippet. We are checking for missing values in the sales column using the isna function, which returns a boolean indicating if a value is missing. We then sum up these boolean values to get the total count of missing entries. Finally, we print out the number of missing values, giving us a clear picture of any gaps in our data. So it turns out there are 30 missing values in our dataset. Let's see how we can handle these missing entries. Your manager might ask, what do we do about these missing values? Well, we have a couple of options. We can fill missing values using forward fill or backward fill methods. Forward fill assumes that the most recent sales figure should be carried forward, while backward fill assumes that missing values can be replaced with the next available value. Let's go ahead and apply forward fill to our dataset. So what we are doing here is using the fill NA method to fill missing values. We specify the method as fill, which stands for forward fill. This method carries the last valid observation forward to fill the gap. By setting in place to true, we modify the original dataset directly. After executing this, we print a confirmation message to indicate that the missing values have been filled. Now, your manager is interested in seeing monthly sales trends instead of daily fluctuations. To achieve this, we'll resample the data to get monthly totals. This will help us identify broader trends over time. Here's what's happening in this code snippet. We use the resample method to change the frequency of our data to monthly, indicated by M. The sum function then aggregates the sales data for each month. This gives us a new data set with monthly sales totals. Finally, we use the head function to display the first few rows of our resampled data, providing a quick look at the monthly trends. Your manager might ask, can we smooth the data to see long-term trends? Rolling averages are a great way to reduce daily fluctuations and highlight long-term patterns. Let's see how we can apply this technique. We are creating a new column called rolling_7D_AVG in our dataset. This column calculates the rolling average of sales over a 7-day window using the rolling method. The mean function then computes the average for each window. We then plot both the original sales data and the rolling average on a graph with a figure size of 10 by 5 to visually compare the two and observe the smooth trends. In the plot, the blue line represents the actual daily sales, while the orange line is the 7-day rolling average. This rolling average smooths out short-term fluctuations, allowing your manager to see clear trends without the daily noise. It's a great way to visualize long-term patterns. Next, let's talk about detecting seasonality. Your manager suspects that sales follow a seasonal pattern. To investigate this, we'll group sales by month to see if some months consistently perform better than others. This will help us identify any seasonal trends. Here's what's happening in this code snippet. We start by creating a new column called month in our dataset, which extracts the month from the date index. Then we group the sales data by this month column and calculate the mean sales for each month using the groupie and mean functions. Finally, we plot these monthly averages as a line graph with a figure size of 5 by 2, allowing us to visualize any seasonal trends in the data. Here are some key insights from our seasonal analysis. Sales tend to peak from March to May, indicating a spring sales surge. There's a decline between June and October, which could suggest a mid-year slump. Finally, sales increase again in November and December, likely due to the holiday shopping season. These insights can help in planning marketing strategies. Now, let's focus on detecting anomalies. Your manager wants to spot any unusual sales spikes or drops. To do this, we'll use standard deviation to identify outliers in the data. This will help us pinpoint any unexpected changes in sales performance. So, what we are doing here is calculating the mean and standard deviation of the sales data using the mean and STD functions. We then identify outliers by checking if any sales values are greater than 2 standard deviations above the mean or less than 2 standard deviations below the mean. This is done using a Boolean condition. The resulting outliers are stored in a new data frame, allowing us to examine these unusual sales events more closely. Here are some insights on the anomalies we've detected. High spikes in sales may indicate successful marketing promotions or holiday sales. On the other hand, sudden drops could suggest supply chain issues or changes in customer demand.
Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.